So for this right here, you will be doing trig sub. And of course, you should know the trig sub table. And let me just review that with you guys real quick. Here is the expressions that you are going to see. And this is the substitution that you are going to use accordingly. And then lastly, here will be the identities that you have to use. So we have 3 parts. First, if you see square root of x squared, let's do a squared minus x squared. Notice we have a number square going first and then minus x squared. In this case, we let x equal a times sine theta, because once you plug in this into the x, factor out the a squared, you will see that you get 1 minus sine squared theta. And this is equal to cosine squared theta. The idea behind trig sub is that, you see here we have 2 terms, but this is just 1 term. Better yet, this is a perfect square. So when we do this, it's kind of like complete the square inside of the square root. And we know when we have square root and a square, they cancel each other out very nicely. Before we go to the next one, I want to mention a small mistake that people usually make. Actually, the big mistake people usually make. They don't differentiate this, so I would like to include the derivative right here for you. Dx is equal to, a is a constant, you keep it. The derivative of sine is cosine theta. Make sure you use this right here as well. But this is actually not a substitution that we want to use, because this is the function square minus 1 square. So let's see, I'm also going to give you guys another one. The next one, a squared plus x squared, but the order of addition doesn't matter. So let's write it as x squared plus a squared as well. If you have addition in between, you use tangent. And remember the derivative for tangent, a is a, tangent derivative is secant squared. Thank you. It's also on the board right here as well. Anyways, the identity that you have to use is 1 plus tangent squared. You will get secant squared. Lastly, square root. If you have some x squared and then minus some number squared, this is for this situation. You use secant. And then the derivative for it, derivative secant is secant theta times tangent theta d theta. And the identity for this is secant squared theta minus 1 gives you tangent squared theta. So this right here is the trig sub table that you should have in your notebook. And technically I will say this right here applies to more than just square roots. But in this section, usually you will be dealing with square roots, so keep that in mind. Anyways, notice that x squared minus 1 is like 1 squared. So we'll be using this, where a is equal to 1. So your first move is, let x equal 1 times secant theta. And remember, we need the dx as well. We need this part. Dx equals secant theta times tangent theta d theta. Now, we just have to plug in this into the original expression. And when you are doing this for the first time, I'll tell you, this is hard. It's okay to go slow. It's okay to struggle here and there, all right? So just stay calm. Here we have the square root. X is secant theta, but we have to square that, minus 1, and then over the bottom, we get secant theta to the 4th power. A lot of students, they don't like to put down the dx, and that's dangerous. Make sure you don't forget the dx. It's right here. Secant theta times tangent theta d theta. Now, this is why that you really have to know your fundamentals really well. Next, we'll be simplifying all the trig identities and things like that. Inside here, secant squared theta minus 1 gives you tangent squared theta. So, don't forget to write down the integral and then the square root. On the inside, we get the tangent square theta. And then usually we like to put down the power right here, so that's secant to the 4th power. And then we still have this. Now, square root and square cancel. This is what I told you. When we do trig sub, it's like completing a square inside of the square root. Very nicely. Alright, I do want to mention that usually when we cancel the square root and then the square, we have to put an absolute value. But I will tell you, when we are doing trig sub, you don't have to worry about that. Why not though? I do have a video going over the details. If you want to see that, the link will be in the description. But for now, I'm not going to write down the absolute value. And then right here, you can see that this is secant theta. We can cancel one of them. So on the bottom, we have 3. Now, this is tangent theta, right? Just one power, but we have another one. So together, we have the second power. Earlier here, we cancel one of them. So this is secant to the 3rd power. Like this. So this right here is about the simplification. Now you have to recognize, can you integrate this right now? Meaning, can we do u substitution or anything to break it down? Or do we recognize the derivative Hua function will give you this right here? And as I said, this is not easy. The fundamentals will help. Notice right here, we cannot do u sub or whatnot right away, so we are going to simplify this expression a little bit more. Instead of working with tangent and secant because we have the fraction, maybe let's try to work with sine and cosine. So on the top for the tangent, this part, tangent square is the same as saying sine square over cosine square. Because tangent is sine over cosine, when you square, just square each of them. And then on the bottom, okay, 1 over cosine is secant, but if you have 1 over secant is regular cosine. So when you bring this up, it becomes regular cosine. And then we have that to the 3rd power. And you see this actually works out rather nicely. Because now we have more cancellation. It's just the 1st power. So sine square theta times cosine theta d theta. If you look at this right now, how can we continue? We have a cosine factor here, and this is an expression sine theta squared. Right here, if you say u sub, great, because yes, we can just do a u sub for it. So let's go ahead and do that right here. I'm going to do u equal sine theta, and it's just to the 1st power. So once you get to this stage, if you are still not sure about how to do u sub, it's a great idea to go back to your u sub section and then review all the u sub and also the technical part. I do have a video on how to choose the u. Again, you guys can watch that. Link will be in the description. But anyways, right here, take the derivative. The derivative of sine is cosine. Have a look. This right here is nicely equal to our du here. So this right here is our u. Square that, we have u squared. And then this right here is our du. And in the u world, most likely you'll just be doing the reverse power rule or recognize the derivative Hua function will give you this. Sometimes in the u world, you might have to do integration by parts, but that's for another story. For this one, we do the reverse power rule. Add 1 to the power and then divide it by the power, we get 1/3 u to the 3rd power. And that's pretty much it, right? We finally did the integration step. Finally, seriously. Now, we're pretty much done with the calculus. We'll have to go back to the x. So the rest is just about some pre-calculus stuff. So first, I'm going to put the sine theta for the u. So this is going to be 1/3 sine theta and then to the 3rd power. And notice I haven't put down the plus c yet because I usually just like to write down the plus c at the very end, especially we're just doing an integration question. Just put down plus c at the very end, that's fine. Unless your teacher really wants you to put down plus c here, then just follow your teacher's instruction. Now, we are back to the theta world. We still have to get back to the x. How though? we are going to look back to what we did right here. X is equal to secant theta. So secant theta is equal to x. Let's write this as x over 1. This way, you will see that the top for secant is what? Hypotenuse. And the bottom right here is what? Adjacent. So you can come up with your triangle like this. Put a triangle here, and then the theta here. Hypotenuse is x. Adjacent is 1. And to figure out this side, you open the square root. The quick way to do it is just open the square root. Take the hypotenuse squared minus the other side squared. That's the quick way to figure out the missing side. Here's a bonus tip for this though. Here's a super quick way to figure out this. The square root part is always going to be from the original integral. It has to, right? But anyways, the purpose of this triangle is so that we can figure out the sine based on this triangle. Secant is equal to x over 1. What's sine? Sine theta is opposite over hypotenuse. So we have 1/3, and I'm just going to enter square root of x squared minus 1, which is the same as 1 squared. And then that is over x. And then cube that. If you leave the answer like this, that should be okay. Sometimes you may want to distribute the exponent, but that's fine in my opinion. This is actually more clear. So just like this. So you see, it might take you like a while, 10-20 minutes to do the question, but it's okay. You are learning this for the first time, it's okay. But now, not too fast to move on to the next question. Let's go ahead, erase all this, and try to see if you can do it 100% on your own or not. Alright? So seriously, let's go ahead and just erase it. Let's just go ahead and erase it. Or maybe you don't have to erase this. Just get a sheet of paper, or on your iPad, just go to the next page or so. Have a look. Now it's your turn. Put away, close this video, put away your notes or whatnot. Look at this, look at this. Try to see if you can do it 100% on your own or not.